Hello and welcome to today's video. So on the workbench today, we have a disassembled BC3300 battery charger. Yeah, so we're going to be able to go through and see what the failure mode was on this charger. If my voice sounds a little bad, it's because we had a company tailgate football game and there's some cheering and I lost my voice. You know, the usual stuff. But so I got the power stage here. I've checked it out. It's fine. All the MOSFETs, IGBTs, diodes, everything looks good. I didn't find any shorts or opens. Transformer checked out good. We don't have any shorts between the primary and secondary and to ground. So that looks fine as well. Those cracks that we found in the epoxy in the last video, or in the potting compound, they're purely cosmetic. It doesn't look like it actually affected anything. There is a little burn mark here, but that's not from this board, it's from this board. So if you imagine this guy sits on top of here, if we flip it over, you can definitely see that this is what was smoking. Oh, let me try this. Does it look better with the light on? Yeah, not too bad. So this guy, this via or through-hole pad is what was arcing. Got really hot. I don't know if you can see it moving, but that is no longer making contact. There are a few more that are bad, like this guy up here looks pretty bad. Everybody else looks okay. That guy looks a little crusty. That guy's definitely bad. That guy's going on its way out. That guy looks kind of bad. But yeah, they all don't look like they're very good joints. So we got that, and then of course if I flip it over here, ignore this connector for now. I'll get to that here in a second. You can kind of see down in here where that cap has been arcing. Got really hot. He's actually really bloated. Probably doesn't come across in the camera, but I got a piece of paper. Normally you can, yeah, see, it won't. It's yeah, can't get it to where you could see down in there, but it's not a square anymore. It's bloated out. It's pretty fat. There are a few like that. These guys, it just doesn't. I don't know if that comes across. That, yeah, they've gotten really hot. These guys are the this is a zero crossing forward power converter. So essentially, the bridge rectified voltage, the bridge rectifier coming out of here, so you got either 120 or 240 bridge rectified DC, appears across these guys, this whole cap bank. So these guys are in series, and these guys, so all of these guys are essentially in series, but this center tap part is what actually gets pumped through the through here, and that allows it to, you're essentially discharging the capacitor into the inductor, the primary, and then, you know, doing the opposite. So when it'll go down, it makes a nice sine wave. When it comes back to zero, it turns the other one on, and so these little IGBTs just kind of fire that back and forth. That guarantees that this is always going to be crossing zero when they switch. So it puts very little load on the power components, but it puts a lot of load on these capacitors. So these poor capacitors are switching about 50 to 60,000 times a second, just back and forth, back and forth, back and forth. And so you're pumping, you know, 3.3 kilowatt. This is 3.3 kilowatt battery charger. So you're pumping 1.5 kilowatts through these caps and 1.5 kilowatts through these caps. And they get hot and they just get nice and warm. And those thermal cycles add up, and that's what causes the vias to, or these through-hole pads, the pin itself kind of like mechanically pushes and pulls in and out, and enough times it breaks down. Once it starts breaking down, the solder starts breaking down, then it starts arcing really bad, and you start getting these failures. So I'll probably end up just replacing this whole board. You can also see, yeah, this connector here got a little toasty. It's melted. I'm not sure if we've got a short. These are the pulse transformers, so it'll actually they send some they toggle these guys, and it goes through. This is just a ribbon cable wrapped around a ferrite core. but if you look at the way it's built, it's probably hard to tell, but every other wire goes to here, and then every other wire goes down to here. So essentially you end up with, so this has 4 wires going to it, so there's 2 independent circuits, and then you end up with, those are what tell the plug into here, and that's what tells the primary side MOSFETs, which are all, you know, down in here on the sides here. That's what tells them to fire. It causes it to actually do its thing, to turn on and turn off. But yeah, anyways, so this guy, you can see we've had a little damage here. So I don't know if it's a short in this somewhere in here. I didn't really see anything. More likely we probably just melted, because this is the gate driver board, and it goes on here like this. It kind of lives right here, so you can kind of see the board got really hot. So yeah, the epoxy has started coming out of the circuit board fiberglass. That's never a good sign. If we flip that over, you can see where that connector was plugged in is just a melted blob, and it looks like we've lost some MOSFETs in there. These MOSFETs are what drive these pulse transformers and do the toggling for the gates of the MOSFETs. So yeah, it looks like it's seen better days. I haven't decided yet if I'm going to repair this. I gotta clean it all off and see how bad it is. It doesn't look like, I mean, yeah, I'm a little worried because it looks like we did get the board really hot. It definitely has a nice magic smoke has been released odor to it. But yeah, I'm probably gonna replace it. I don't know if it's worth fixing. Then it just becomes a spare part, so if I need one of these chips, I can just take it out. But yeah, I might replace that from the spare part bin, spare part charger. Other than that, all the other joints on the other boards look fine. I didn't see anything messed up. Interesting thing here, there's an impact mark from a capacitor that exploded, but it's been replaced. So somebody's repaired this before, because see, this has got a T-shape on it, and this mark is a Y shape, like one of these kind of caps. So you can see they're all the same style except for this guy. So somebody's actually repaired this before. I looked through my records, it wasn't me. It's really easy to tell if I've repaired something. You type in like the BC3300 and then underscore, like in this would be 1161 on my website, and it will, if I've repaired it, that's how I keep track. Serial number record, the last 4 digits, or the URL is actually the serial number. So I know things get traded around on eBay a lot, and cars change hands and things like that over the years. So if you ever want to know if I've worked on something before, you can type that in, and that should pop up. But yeah, so somebody's repaired this before, and not only that, they've repaired this entire voltage sense circuit. So this is the output voltage sense, and somebody went along and replaced all of these parts, including all of these diodes and the linear photocoupler. I know that because I've actually cleaned it up, but they did a horrible job. Like, it was just all nasty and crusty. So I've kind of cleaned it up. But yeah, it's like this whole section in here has been replaced. So somebody's obviously did some repairs to it before. And no, that's just a connector there. But I did clean up all the solder joints, well, most of them, and fixed any of the pins that were bent over in the last video that looked like they could be shorting. Except, does that look like one right there? No, that's separate. Yeah, so I've gone ahead and did that. I also repaired the connector. So clean it up a little bit. Now it's on there like really good, like it's not going to go anywhere. So this whole thing got destroyed, bent up, broke pins, but I've re-anchored it with some added pieces that I've soldered on here. The other side was okay, it was just bent, so I fixed that, soldered that back in. And then I went ahead and just soldered in little, they're wire wrap connector posts, and soldered those into the board, and then soldered this on. Very precise precision soldering between the pins. But yeah, that's on there solid. It's not going to go anywhere now. You can, yeah, that's should be good. And then reconnected this diode bridge that they've got here going on. Put that back on, and yeah, that looks like it came up pretty good. Oh, and I replaced the two blue caps because they were rubbing in the case enough that it actually you could see the metal of the capacitor, so I didn't trust them anymore. So we now have yellow ones instead of blue ones. Yeah. So that's where we're at. Quick overview. Get with the customer and see what they want me to do, but I think I'm just going to replace both these boards. I don't know. This connector's pretty messed up, and the board itself, you know, once those vias start going, there's through holes. Like, even if I clean that up, you know, the other side, if I pull that cap out, it's just gonna pop the thing off the board because it's just been melted. So yeah, I think it's replace this guy. I don't know if I might go in there and repair it. I gotta figure out. You know, who knows how far back it is. And the way this thing sits in here, it's really awkward to get at because you got to put the whole stack back together. So it's really hard to troubleshoot. It might be easier just to put a known good one in. Because, yeah, we know something went wrong with these guys, these MOSFETs, but we don't know how far back it is. Like, it could be part of this driver circuit, could go all the way back. You know, it could be where it comes in, goes through the whole thing. Who knows? Be a lot of troubleshooting. So, might just swap Tronics it and be done. Get it out so I can get back to working on the truck. The repairs, they're great, but it brings in money for Wolftronics, so I can afford to do stuff, but it does take away time from working on the truck. I'm so far behind. I don't have it pulled up right now, but I've been working on the ICD. I'm up to like 1,200 lines in Excel for like what all the CAN messages mean, all the identifiers and everything, for all my boards to talk to each other. And then I've been implementing that in code. So it's really boring stuff that nobody wants to see. I mean, it's just me writing code and filling out an Excel spreadsheet. So anyways, yeah, again, excuse the mess, excuse my voice, and thanks for watching. Bye.